Hi guys. Hopefully you got that text that I sent last night to remind and you realize I won't be there today. I'm sorry, I know we were learning something new and we were going to use today to practice. I still want you guys to practice. Sorry, that's my clock. But I wanted to go over a few more things with you. This one was the one that we did not finish on the notes. Hold on, I'll wait till it's done. Okay, this is the one that we did not finish from the notes. And then I have two more additional examples that you guys can kind of add on the bottom of your notes. And then I wanted to go over that number 12 that we didn't do from the homework, or that I told you to skip from the homework. Okay, with something like this, the first thing I would do, like we always check, is see if there's a GCF. This one does have a GCF. So the first thing I would do is factor out the Okay, at that point, this is the trinomials that we're used to solving. Okay, so we're saying two things. We're trying to multiply to negative 24. We're trying to add to 5. And what are those numbers? Okay, those numbers are 8 and negative 3. So initially when I factor this, it looks like x squared plus 8 and x squared minus 3. Now, hopefully you realize we're not done yet because we have a lead coefficient. So we have to take that 4 and divide it out of everything. So really we have x squared plus 2 and 4x squared plus 3. Now, like we talked about yesterday, at this point, factoring's done. That's great. I still need to set everything equal to 0 and solve all these guys. So I need to say that 2 equals 0, which hopefully we know by now that's really not going to generate much solution-wise. Now, again, this doesn't give me anything. Okay, that second one, x squared plus 2 equals 0, I can solve this. I subtract 2 from each side. I get x squared equals negative 2. Now, the way I solve this is I take the square root of both sides. Hopefully we remember from some of the work that we did with radicals that if I take the square root of a negative number, first of all, I don't want you to give me a decimal answer. And second of all, if it's negative, I should get an I in my answer. So these two, or this one ends up generating a solution that looks like plus or minus I radical 2. Because there's nothing else I can do with that. So there's 2 of my answers out of the 4 that I needed. For the other one, I have to subtract 3 and divide by 4. So initially I get x squared equals negative 3/4. Again, I take the square root of both sides. Okay, once again, taking the square root of a negative number is going to give me an I. But even before all that, when I take the square root of a fraction, I can kind of distribute that square root, so to say, to the numerator and the denominator. So right now I'm looking at plus or minus I, that's the negative part. And really I have the square root of 3 over the square root of 4. Well, this one is way better than the one that we did yesterday in class, because even though 3 is not a perfect square, 4 is, so I don't have to worry about the radical and the denominator stuff. So really I have plus or minus I radical 3 over 2. And this one's okay. I don't have to do any of that extra stuff I did yesterday because I don't have a radical in the denominator. I'm allowed to have a radical in the answer as long as it's not in the denominator. Okay? Now, again, because all 4 of these answers are imaginary, that means if we looked at the graph on the calculator, none of these would cross the x-axis. It's going to have 3 of those turning points. That makes it a degree 4. But at nowhere in this graph will it cross the x-axis. Okay? Now, this one I want you to add on the bottom. The first thing I want you to do, take a second, pause the video, and just try to factor this, and then we'll talk about the solving. Okay, here's what I got when I factored it. Difference of cubes. Cube root of each one in the first set of parentheses, and square the first term, and multiply together and change the sign, and then square the last term. Now, if that trinomial could be further factored, we could factor it. But if I'm looking at this trinomial, you're talking about things that multiply to 16 and you have the 4. That just doesn't exist. So I have to solve these. The good news is the first one's linear, so it's a pretty easy solve. X minus 4 equals 0, add 4 to both sides. So this one is at 4. So there's one of my 3 solutions. Now, the problem with the other part, it's quadratic. Well, good news for us, sorry, it's a little messy, but good news for us is that we spent a great deal of time solving quadratics. We solved them by factoring, which we can't do this anymore. We solved them by looking at the graphing calculator, but our most foolproof, surefire way is solving them with the quadratic formula. So what we have to do here, as not fun as that would be, we have to use the quadratic formula. So that's that thing where we're saying opposite of b plus or minus b squared minus 4ac all over 2 times a. And we have to go through simplifying this just like we did when we did the quadratic formula before Christmas. So our first thing is forever and always to do the stuff under the radical. So at that point, I get negative 4 plus or minus the square root of negative 48 over 2. Just like we did when we did this last time, we have to simplify the square root of negative 48. Hopefully we know that because it's negative, there's going to be an I. The biggest perfect square that goes into 48, so I'm going to break this apart, terrible plus or minus, as negative 1. The biggest perfect square is 16. Okay, so then I'm looking like negative 4 plus or minus 4i radical 3. Okay, and if you remember, if all the things were divisible by the same number, we could reduce, not counting under the radical. So 4, negative 4, 4 and 2 are all divisible by 2. So really this looks like negative 2 plus or minus, I'm struggling with that, 2i radical 3. And if you want to say over 1, that's fine, but don't necessarily. So with one of these solutions being real and 2 being imaginary, that means this graph, this cubic function, only crosses the x-axis 1 time. Okay? All right, try this one. Again, go ahead and pause the video. I'm going to do the whole thing on here and I want you to check it. So you start with factoring. I will tell you both of these terms are perfect cubes. So you start with factoring and then solve each factor. Like I said, pause it, try it, and check it. Okay, hopefully we agree. So again, this one, and this doesn't always happen with cubic functions, please keep that in mind, but this one it does. Again, we have one real solution at 3/2 or 1.5, and then we have 2 imaginary solutions. So this graph only crosses the x-axis 1 time. Okay, the last one I put on here is the one from homework that I told you to skip. If you already looked at the homework answers, I did do this one already, but just to kind of walk you through it again. So again, we start out with factoring. To check the GCF, it doesn't have one. It happens to be a sum of cubes, so we go with the factoring. So factor-wise, it breaks apart. The cube roots are x plus 3. Square the first, multiply together and change the sign, square the second. Okay? Once again, if that quadratic could be further factored, we would, but you're trying to multiply the 9 and add the negative 3, and that doesn't happen. So from this point, we're solving. Solving the first set just requires subtracting 3. So one of my solutions is at negative 3. Solving the second set will be a little bit more involved. But again, one of the things I told you before Christmas is that factoring and quadratic formula was going to be something we were going to need a lot throughout this year, and it just is true. So I think that you guys are very good at quadratic formula, so I hope one that does isn't a big deal. But again, opposite of b, plus or minus b squared minus 4ac all over square. The next thing I always want to do is simplify what's under the radical. That gives me the square root of negative 27. And I break that apart. Factor out that -1. The biggest perfect square is 27 is 9. So this looks like 3 plus or minus 3i, radical 3 over 2. And this one cannot be reduced. So that's what I'm looking at. Okay? Again, if you looked at this in the graph, and I encourage you to, if you go to your graphing calculator, it will work more with the graphing calculator tomorrow. But if you go to the graphing calculator, go to y equals, and plug in x to the third plus 27, you should see that graph. My calculator was working on my computer. I would show you myself, but you can do that and hit graph. And this, you won't see the whole thing because actually most of this graph happens above the viewing screen, but you will see this cross the x-axis at -3 and it doesn't cross any other time. That means those other two solutions are imaginary. Okay, so at this point, if you haven't already, I posted the homework answers on Google Classroom, so go ahead and check those. And then the sub has a worksheet for you. The front is factoring practice, so just factoring. So on the front, all I want you to do is factor, no solving. The back is factoring and solving. So make sure, hold on a second. Sorry, that was one of my kids. Make sure that on the front, you're just factoring, no solving. And it could be everything. It could be the new stuff, difference in sum of cubes. It could be the factor by grouping with 6 terms. It could be any old stuff that we've done. And then the back is factoring and solving. Okay, so hopefully this is good. Please feel free to work with a partner. I know I'm not there, so the desks aren't back in tables yet, but they will be come Wednesday. Okay, so please feel free to work with a partner and let me know if you have any problems or questions. Thanks, guys.